Welcome to UWO Now. I'm Wendell Ray. UWO Now is the place where we discuss relevant and interesting topics with the students, staff, and faculty at the University of Wisconsin-Oshkosh. I think it's safe to say that humans have always been intrigued with the objects we see in the sky. The sun, the moon, and the bright twinkling stars above us. The Artemis rocket, the Orion mission to explore space and build a base on the moon indicates NASA is still moving forward with exploration of what's above us. The Hubble Space Telescope and now the James Webb Space Telescope bring distant galaxies closer with dazzling photos. To help us focus on what we are seeing is Dr. Terry Gee. She is the director of the Barlow Planetarium on the UWO Fox Cities campus in Menasha. We're so glad that she's with us here today. Thanks so much for joining us.
Thank you for having me.
Now, you are director of the Barlow Planetarium at our Fox Cities campus. But tell us about who you are and how you got here. What's your path to getting to Menasha?
All right, so I grew up in Idaho in a small town called Sugar City. If you've heard of it, I'll be impressed.
Oh, sure. I've been there.
And my first my first memory of being interested in astronomy was when I was in first or second grade, and I went to a planetarium, and I was able to look at the night sky and see it projected onto this dome. And it was a really simple show. It was a show about what the scientific explanation could be for the Christmas star and for how the Christmas star could have existed.
Oh, nice. Okay.
And I remember sitting in there in the dark, just being so excited about it. And coming out of that, all I could think about was the night sky. And so we had a book in my house called Our Universe, which was put out by National Geographic. And I read this book cover to cover multiple times. And it had really nice illustrations because it was National Geographic.
Yeah.
And I would go out in my backyard and look up at the sky. But I never got to look through a telescope till I was in college because we didn't have one. And I remember when you mentioned the Hubble, when the Hubble Deep Field was first released, we just got dial-up internet. I was in high school. Yeah. Yes. I don't know how many students even know what that is anymore.
That sound that I just made everybody who was of that age knows exactly what I'm talking about. Yes, but dial-up, which was innovative at the time.
And so exciting. And the first website I went to was nasa.gov.
Okay.
And I found the Hubble Deep Field image, and I got permission from my mom to download that image. And it took an hour.
Oh, wow.
And that meant we had no phone for an hour.
Oh, no wonder you had to get permission. I got it. Okay.
And so when I got it, I actually got also then permission to print it off because in my mind, I thought I will never get to do this again. Which, of course, now you can download that for in like 10 seconds.
Yeah, right.
But I kept it. I don't think I have it now, but I kept that picture for years after. I was so excited to see that. And so when I went to college, I was going to be an astronomer. That was my goal. But I ended up changing over from doing astronomy, from physics to history as my major, history teaching, and physics teaching as my minor, and with the idea that I would do secondary ed. And then I decided to go to graduate school instead, and I studied the history of science, specifically astronomy, and got my master's degree and my PhD in that, always doing astronomy. And I would, all along the way, do little presentations for different groups. So I had people in church who would ask me to come and do it. I would sometimes get telescopes. Once I just did it in a gym, setting up students as planets and the sun. and doing it that way just so that they could get an introduction.
Having to move around.
And having them move around to show the movements of the Earth, the Moon, and the Sun. And so then when I finished, I was in Toronto for graduate school, and then I went back to Idaho and started working at BYU Idaho in Rexburg in their physics department. And I taught a number of classes there as an adjunct and then visiting faculty. So when my visiting faculty job ended, I needed a new job, and I started looking around for something new. And what I ended up finding was the Barlow Planetarium position. And I was really excited because it was a chance to do as my job what I'd been doing for fun all the years before that.
Okay, let's unwind some of that stuff that you just talked about. First, let's talk about you majored in or got a PhD in the history of science.
Yes.
Now, what does that actually mean? What did you study? How science has evolved over the years? What is the history of science?
So, history of science means you're studying how science was practiced in the past, and you can go as far back as there are records. In fact, one of the earliest records we have is actually a lunar calendar that is carved on a piece of bone that is 30,000 years old.
Wow.
They just, whoever they were, because they didn't have a written language, so all we have is this bone. They carved and you can see the progressing moon getting larger and larger and then getting smaller and smaller. So we know that they were observing the moon 30,000 years ago. That's part of the history of science.
Where was that found?
That was found in, let's see. I think it was found in Europe. I think somewhere in France. I can't guarantee.
Well,
it's somewhere around there.
That's just so fascinating. I was wondering where that might have been, but okay.
Yeah.
Somewhere in Europe. All right.
Yeah. And now my area of expertise doesn't go back quite that far. I studied Greek and Latin astronomy. And then I also ended up for my dissertation studying medieval Muslim astronomy and how all of these different groups are connected. So I kind of followed some ideas from ancient Greece, then into Rome, then into medieval Islam, and then into medieval Europe, and just kind of traced this concept through. And so my area of expertise, as far as my dissertation went, ended at about the 14th century. But because I love astronomy so much, I have taught about it all the way up to 20th century, and I have kept up with a lot of the current discoveries in astronomy just because it's so fascinating.
Yeah, and you mentioned something else when you first spoke to us, and that is about when you were back in Idaho as a little girl, you had not had the opportunity to see the stars or the night sky through a telescope. Mm-hmm. If just me, regular guy now, wanted to get a telescope, what difference would that make in what I'm seeing? And I'm not talking about some super telescope, but just something that, someone could purchase. Yeah. What kind of difference would that make for me?
So as far as stars themselves, not much. Stars don't look a lot different in a telescope versus what you see. Okay. They might be brighter. But planets, nebulae, things like that are going to look a lot more detailed. So if you look out at the night sky right now, they rise pretty late at the moment, but they're rising earlier as we go through the fall. Jupiter and Saturn are up. If you know where to look for them, you can see them. They're just little yellow dots. They look different from stars because stars tend to be more twinkly.
Okay.
And planets tend not to be.
All right.
If you're looking through a lot of atmospheric distortion, so if there's a lot of smog and stuff, it's harder to tell the difference. But generally speaking, you can tell the difference with your naked eye between a star and a planet. But if you take a telescope, and it doesn't have to be a big one, you could get a 2-3 inch reflector, which would be using mirrors, and you set it up and point it at Saturn, and you can see the rings of Saturn.
Wow, really?
Yeah.
Okay.
I mean, you may not be able to see any of the moons of Saturn. You may not be able to see a lot of detail on the planet itself, but you will be able to see that Saturn has rings. On Jupiter, you'll start to see the bands of color on Jupiter. And maybe if you're lucky, you might see a couple of the Galilean moons in a smaller telescope. If you get a 6-inch reflector, though, you will see the 4 Galilean moons. You will see probably Titan around Saturn. And if you point it at a nebula, you can see the shape of the nebula.
Now, do I have to know this stuff, where it in the sky? Where could I find that information to know where to point my telescope?
So there are star charts available online for free. All you have to do is type in star chart and you can find it. There's a program, well, you can get an app on your phone, but they also have a website called Stellarium. And it is, you can type in your location and it will tell you what the sky looks like at your location.
Okay.
Depending on, and you can even choose which direction you're facing, what time of day or night it is, and it will show you what it looks like. You can buy books that show you things, but a lot of stuff is available online. One of the things that I used to look at a lot was there's a place called the Sky and Telescope magazine, and they have a website and they do a weekly, what they call Sky at a Glance. And they do for the week, every day, what things are available and where you should look to find them. And so when I was, actually, I forgot to mention this, when I was in college, I actually worked at a small observatory at Utah State University. And I had students coming up to do assignments for their astronomy classes. But when I started working there, I had about a week of training, and then the person who had been there before left. And I had no more training for using a telescope. So I had to figure a lot of this stuff out myself. Mm-hmm. And I would go onto this Sky and Telescope website and start looking. I'm like, okay, what can I see right now? Because I have no idea.
Yeah, what is that?
Yeah.
Okay, right.
And so I would do it that way for a while. And then I started buying myself some books because I wanted to make sure that I could find more than just those few things. But if you get a small telescope, if you're just getting into it, I would say you shouldn't need to spend more than $200 or $300. Don't buy the ones in Walmart.
Okay. We love you, Walmart.
Yes, we love you, Walmart. But I mean, like, the department stores generally don't carry the good brands.
All right.
And so it's not even just Walmart. It's any department store, unless they're carrying something that is like Celestron, Orion. Those are some of the good brands of accessible telescopes, because you can get really expensive with the telescopes you buy. But Celestron and Orion make pretty reasonably priced ones that are actually pretty good. And so if you get reflectors or refractors, so a reflector uses mirrors to make the image larger and to gather light. Refractors use a lens, and the lens bends the light so that you can see it. And either one of them work. Mostly I've used reflectors, and so I'm more comfortable with them, but you can use either one. And if you get one that's $200 or $300 with maybe a couple of little lenses so you can change the magnification, you can see any planet. Well, I don't know about Uranus and Neptune, those are pretty small, but you could see any of the main planets. You can see the moon, you can see probably some of the larger nebulae, and at least see some of the details of the clouds. You wouldn't see this. It's not going to be Hubble images. It's not going to be James Webb images, but you're going to see what they are. You could see the Andromeda Galaxy. I mean, that's visible to your naked eye as it looks like a little smudge in the sky. But in a telescope, you can start to see the shape of the galaxy.
Outstanding. Well, enough about me and my pet interests. But let's talk now, and we'll come back to some telescope stuff because we got to talk about what's going on with James Webb. But what is going on where you are at Barlow? Tell us a little bit about what Barlow is and what people could expect if they visited there.
All right. So the Barlow Planetarium it opened in 1998. There was a planetarium there before, but it was much smaller. And you can still see the smaller dome on the Fox Cities campus, but we don't use it anymore. It's actually been converted over to classroom space. So the Barlow Planetarium, when it opened, it had the best system. It's called a Digistar 2. Digistar is one of the companies that make dome projectors. And it was one of the first fully immersive, full dome projectors.
Okay.
So what that means is the old ones would have, actually, if you go to the Barlow, you can see our old one where it's this little thing where they would have a light inside of a bulb and inside of a ball, and it would shine the different constellations out of these different holes. It worked quite well, but you couldn't do anything but that. These were a chance to do more with the dome space. And so it's basically a virtual reality experience where, because it's completely dark in the planetarium, when the dome starts to move, when we start to move the stars around, you feel like you're moving, and you're not. None of the seats move in the planetarium. We always say if you start feeling a little uncertain, just close your eyes for a few seconds and you'll feel normal again, because it's all your mind not being able to adjust to something moving and you staying still.
Gotcha.
So we have a little fun simulation that we sometimes run of a roller coaster. You go, and all it does is it just shows you going on a roller coaster, but because that's all you can see, your mind interprets it as you are moving.
Yeah.
And so you feel like you're moving. And so we use that to sometimes fly through the stars, so it feels like you're moving through a star field. And so we have shows that are school shows, which are meant for kids coming and getting content for their classroom, so a thing that they are required to learn about. And we have those geared towards from kindergarten all the way up to high school. Then we have the shows that we do for the public, and they range from being fully educational to being fully entertainment.
Okay.
We like to have them all be both, but right now, well, we're heading into our annual maintenance, so it's not open at the moment, but when we start up again on the 21st of September, we have a show running that is a kids show called Lifestyles of the Stars, and it takes a family on a little cosmic tour bus, and they get to go around and see how stars function and why some stars are big and some stars are small and some stars, why their colors are different. And it's all geared towards probably 10 and under. It's great for families to go. We also have, starting in October, a show called Chasing the Ghost Particle, which is about neutrinos. We have another one called Moon Witch, which is another one for kids. And then we also have our laser shows. Now, our laser shows are pretty much just entertainment. It's like going to a rock concert. We have Led Zeppelin and we have Pink Floyd. And then we have a laser projector that projects images using lasers up onto the dome. And so you get to have, again, that kind of virtual reality experience of listening to fun music and seeing fun imagery. And those are purely entertainment. We mostly do those on Friday and Saturday nights.
You mentioned that in 1998, there was some very state-of-the-art equipment that was installed then. What are we looking like now?
Well, so now it's the same equipment as it was in 1998. In fact, next year will be our 25th anniversary. And what we're hoping is that we can start the process of fundraising so that we can upgrade this equipment, because while it was state of the art in 1998, no one uses it anymore.
Okay.
And it's very old. And because of that, it's hard to find backups. And so we want to be able to keep this, the Barlow working and serving the community, because it is used by the community so much. I mean, we have nearly every day people reserving it for different school groups, for scouting groups. And so we're really hoping that we can get an upgrade to this equipment so that it can continue for another 25 years serving the area. We have had groups coming in from Manitowoc, from Green Bay, from Fond du Lac. We get school groups coming an hour or more on the bus just to be able to come to the Barlow Planetarium. And so while the equipment still works and it's really still a great, fun time to go, we really want to bring it up to date.
And what does state of the art look like now? What kind of things could the planetarium present to the folks in Menasha, the Fox Cities campus, with new equipment?
All right, so the Digistar company has continued to develop, and they switched from we're analog right now, and they switched over to digital about, I think, 10 or 15 years ago. And so what they're on now is called Digistar 7. So it's 5 models newer. And it is still fully immersive, but now it is fully immersive, all using digital projectors. And so what that means is, for one thing, color. The dome we use now, when we show the shows, the actual recorded shows, those have color in them. But when we do the stars are all black and white. The sun is white. The moon is white. We don't have any color options. But with the new Digistar systems, as far as just showing a star field, you will get to see this star is a red star, this star is a blue star, and it will actually look like that. We'll be able to do, we'll be able to do more stars being projected onto the dome. I think we can do 12,000 right now, which is a lot.
Okay.
It's
Sounds
really
like a lot.
Oh, it is. It's a wonderful experience sitting under the dome when we do the perfect sky. But we can do even more when we're using a digital projector, because that will give us a more accurate view of what the sky looks like. So at BYU Idaho, they had actually just recently upgraded their planetarium, which is a lot smaller dome than the Barlow is, to a Digistar 7. And one of the things you can do, which is really fun, is you can, if you can set the sky to what's up at that time, and then if there's a planet up, you can zoom in. So you can basically take this little dot, which is the planet, and then like you're zooming in with a magnifying glass and make it take up the entire dome.
Oh, wow.
And just see it right there. And you can do that with any planet. You can do it with different, like the nebulae, with galaxies. And then with the shows are all updated. So with new information and everything, that's one of the hardest things for us now, is updating the material to reflect the new discoveries. So there are shows that talk about the beginning of the universe, the Big Bang, all the way up to today. There are shows that talk about dark energy and dark matter, black holes, and all of those kinds of things are all different shows that we could get, because our system is so old, no one makes shows for it anymore.
Right.
And so we can't buy those, but with a new system, we would have access to that whole catalog. And so it would be a whole bunch of really new and fun shows that we could still do. And we would still be doing, introducing to constellations and planets and all of that basic stuff, but we could do more.
Got you. You're listening to UWO Now. I'm Wendell Ray, and today's guest is Terry Gee. She is the director at the Barlow Planetarium, UWO Fox Cities campus in Menasha. Now, just as we talked about upgrading Barlow, there was an upgrade with a telescope that's in space.
Yes.
We went from we're now with the James Webb telescope. What was the big upgrade and difference? I remember when we first saw those images from Hubble, and I guess the one famous image is of this birth of a star or a galaxy or birth.
Yeah, the pillars of creation,
Yes.
they called it.
I saw that, but I didn't have a clue what I was looking at. I mean, it looked really cool, but I didn't know what I was looking at. But now, even still, what we have with the James Webb telescope is that we see farther and clearer. Is
Yes.
that correct? All right. So let's talk about some of those images that come through. Some of the things that we're seeing. What are we learning about the galaxy that we may not have known before as a result of this bigger and better telescope?
All right, so one of the main differences between the Hubble and the James Webb is that the James Webb is optimized for infrared wavelengths. So if you look at light isn't just the light we see. Light ranges from gamma rays and X-rays, which are very, very short wavelengths, but very, very high amounts of energy, all the way over to radio waves, which are very, very long waves and don't carry a lot of energy. So between visible light, which is what we see, which is kind of right in the middle, and radio waves, which are the lowest energy, there's infrared. So infrared is the wavelengths of light that we give off. We usually talk about it as like heat.
Okay.
So if you wear night vision goggles and you have ever done that and you see the little green shapes, what they've done is they have taken the heat generated by people and converted it over into a wavelength that we can see, in this case, green light. So the James Webb is optimized for those wavelengths. And why that matters is that its main function is going to be studying the very, very early parts of the history of the universe. So the further we look away from us, the further back in time we're looking, because light has a finite speed it travels at. It's 186,000 miles per second, which, yes, that's really fast, but it still is a limit. And so the closest star to us is 4.3 light years away. And I can't remember what the exact number is. It's something like 7.8 trillion miles.
Wow.
And so, I mean, and that's the closest thing. So when we start looking further and further away, we're looking at light that started traveling to us a long time ago. And so we're actually looking back in time. And what the James Webb is supposed to be doing is showing us how the universe formed. So we're going back, we can't go all the way back to the Big Bang, but maybe 300,000 years after the Big Bang.
Okay.
And because the light's coming from so far away, and because the universe is expanding, the universe is actually stretching the light out away from the higher wavelengths that it probably was at originally to infrared. So if we're looking for it, we want to look at in the infrared wavelengths. So that's what its main goal is going to be. But right now, at the very beginning, what they're doing is they're testing the equipment, making sure it's all working. And so
We're still in the testing phase?
yeah.
Okay.
Yeah.
All
So
right.
I mean, they are getting data, but they're seeing how good the data they're gathering is. So just last week, they released an amazing image of Jupiter.
I saw that.
In infrared.
Yes.
So the reason why it looks so weird is because it was infrared wavelengths that were translated into visible light, where the brighter the colors, the more light was being reflected. And so the ones that are dimmer are less light being reflected, and that's what the scale was for that. But when they first turned it on, they take their first images. They did one that was the Carina Nebula and showing the details of the Carina Nebula. And then they did one that was kind of like the Hubble Deep Field. So, and this was meant to illustrate the difference between the Hubble and the James Webb, because the Hubble Deep Field, they looked at a space in the night sky just above the cup of the Big Dipper. And I think it was something like, I don't know, maybe like an inch or so of the night sky in the Hubble telescope. And they had exposed it for 18 hours, if I remember correctly. And that's where the Hubble Deep Field came from. The James Webb image that they released, it was the size of a grain of sand in the night sky. So if you took a grain of sand and held it out, that's how much of the sky it was looking at. And it was only for a few hours, like 5 hours. And that was all the exposure it was. And we got all of that detail.
Wow.
And so when they start doing longer exposures, gathering more light, what more are they going to be able to see? And one of the other things that they released, which wasn't a pretty picture, but was really interesting image, was looking at other planets, exoplanets we call them. When they're not around the sun, They're outside of the solar system, so we call them exoplanets. We have found something like 4,000 exoplanets, but they're really hard to see because they're so small in comparison to the distance. And so we have to we don't know exactly what their composition is most of the time. But one of the images one of the data packets that it actually managed to gather indicated that there was a planet that had water in its atmosphere.
This is from an image that we got.
Yeah.
Okay.
Now, as far as if what they released was actually a graph.
Okay.
Showing the data, they didn't have a picture,
Okay.
and that's where I think a lot of people kind of said, "Oh, well, here's the beautiful Carina Nebula. Here's this great deep field image, and then here's this graph."
Right.
And so I think a lot of people kind of skipped over the graph, but the graph was really interesting because it showed water in the atmosphere of a planet outside of the solar system.
I got a million questions just off of what you just said. Okay. So let's try to quickly get through this.
Okay.
All right. One thing is, where is the Hubble and where is the James Webb Telescope in space? Where did we send them?
Okay, so they're both in more or less orbit around the Earth.
Okay.
The Hubble is fairly close. And that was actually really important. I don't know if you remember when they first launched the Hubble.
It didn't work.
It didn't work. And so everyone's like, oh, they spent millions of dollars on a piece of junk.
Yeah.
But we were able to send some astronauts up. They went, fixed the lens, and everything was fine. We can't do that with the James Webb. The James Webb is, I believe it's 1 million kilometers away.
Okay. And that's still in our orbit?
It's basically in our orbit. So what it is there's these things in space called Lagrange points. And we're not going to get into all of the details of that, but basically it's a spot where it's easier, it takes less energy to keep it in a stable spot than in other, I keep hitting that, in other areas. And so there's 4 or 5 of these Lagrange points in space around the Earth. And so the James Webb is in one of those. And what that does is that means that they didn't have to worry about as much fuel. It has batteries and it has solar panels so it can recharge, but eventually those things stop working. And so what they've done is by putting it there, they're putting it in a spot where it will use less energy to keep functioning. And that means it can function for a longer period of time. But because it's so far away from us, if there were any errors when they were deploying, so I don't know if you've seen the picture of the James Webb, it looks like it has all that little honeycomb pattern. Each one of those is an individual gold foiled mirror. And they all operate together as one. So they had to fold everything up to launch it and get it out to the Lagrange point, and then they had to do a very slow process of unfolding the James Webb. So they had to unfold the heat shield to protect it from the sun, and then they had to unfold every individual mirror and hope that it worked.
Yeah.
And if it hadn't worked, there's nothing we can do.
Oh, wow.
So some of my friends and I, we were watching because they actually had a website where they were showing which ones were open and how much they were open and how long it would take to open them. And so we were all watching to see if they were all, everything worked perfectly. Now, you might have seen there have been some small meteors hitting them.
Yeah.
They knew that was going to happen. You can't be out in space and not expect some debris to hit. That was expected. One of them that hit was a little larger than they had hoped, but at the same time, well within the margin of what they were expecting.
Did it take the hit?
Yeah.
Okay.
Yeah, it was fine. It still is functioning just fine. As long as we don't have like a full-on asteroid hitting it, it's not going to be a problem.
Okay. Now here's a question that may or may not make the podcast.
All right.
But this is one of my kooky questions that I've always wondered. Okay. I'm in a space capsule or on a spaceship.
Okay.
I can see in front of me, I can see distant stars, blah, 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 blah. If I look down, what would I see?
Well, in space, there is no down. there's only down if there's gravity that you're feeling. So if you're floating in a space capsule that's just sitting in space, down is whatever is below your feet. But if it's whatever you want it to be. So if you're out in space and you're not right next to the Earth, all you'll see is more space.
More black or?
Yeah, well, more stars, because there's stars in every direction.
So beneath there would be stars too? That's what I mean. Okay,
Yeah.
so because, usually when, you see, or it's always just what's in front of you or what's outside or what's above you. But I said, what's below me if I'm out in space? And it's more
stars, because we usually think of it as, it's kind of like when kids draw pictures, it's
a
flats
plane.
and
Yes,
it's a
right.
plane, but we're in a three-dimensional space.
Exactly.
So if you're sitting out in space and there's no other planets or anything around you, you're just out in open space, what you have is stars above, stars over here, stars down here. If there aren't stars down there, that means it's probably a black hole and you don't want to be there.
So some of the images, so some of the stars that have been mapped are what I would say, in my little mind, stars below us.
Yes. Yeah. So if you think of our location in the Milky Way, I always would tell my students, we're not quite, a little bit further than the suburbs of the Milky Way. So you have downtown hub, which is the bulge, the central bulge, and then you have the disk, that is the stars going around the central bulge of the Milky Way. And we are about 28,000 light years from the center. And the disk itself is about 50,000 light years in radius. So halfway. Okay. So so if the disk is a certain thickness, we are like right about here.
Okay.
And so when we look into the disk, that's when, if you go out into a really dark sky and you see the band of the Milky Way, what you're doing is you're looking this way into the disk. And when you're looking everywhere else, you're looking away from the galaxy. So if you want to think of it in terms of, there will actually be, if this is the Earth and the orientation of the Earth, and you're sitting there, and so your down is this way, you will actually see more stars down than you would up.
Wow. Okay. All right. So that wasn't a kooky question.
No, it wasn't.
Okay. Well, take another stab at a kooky question. So we've got the Hubble, we've got the James Webb telescopes, and they're bringing us images from light years away. What are we learning about the planets near us, though? Or can we see them better? Or are we looking at them through these telescopes? And if not, why not?
So we aren't using the Hubble and the James Webb very much for looking at planets, mainly because they're optimized for very distant viewing. We can study planets really well from Earth-based telescopes, which are easier to access, and therefore it's not as expensive.
Okay.
But also, we have been able to send missions to these different planets, and so we learn more from being right there. We have sent, so far, we only have done a couple of flybys to Mercury. I don't think we've landed on Mercury. We have sent a number of missions to Venus, mostly during the 70s space race with the Soviet Union. And so the Soviet Union sent a lot, we sent a lot. But the problem with Venus is the surface of Venus is almost 900 degrees.
Yeah, a little toasty.
A little toasty, and so metal melts. So if you send a probe, I think the longest any of our probes have lasted is like an hour.
Yeah. Okay.
And then they melt. So we have sent missions to Venus, but they don't last very long. We send a lot to Mars, of course.
And we've sent things to the sun too, right?
Yeah, we have. We have the Parker probe that has gone into the sun.
How in the
or
world
we'll
did
get
that
there.
happen?
Well, no, it was the intent.
I mean, but if things are melting on Venus, how are they not melting when they go to the sun?
The intent is for it to basically melt.
Oh, okay. Okay.
They're what they want to do is send it as far in as they can and get data as long as they can before it destructs.
Wow. Okay. Oh, okay. So it's a kamikaze mission.
Yeah,
for that
it is.
Poor little thing.
Yeah.
Okay. All right.
And then we've sent missions, lots of missions to Mars. We have sent the Juno mission to Jupiter. And then we have Cassini that went to Saturn. But we have not sent any missions to Uranus or Neptune. I keep hoping they will, because people say, well, they look kind of boring. I'm like, well, yeah, they do, but I'll bet they're not.
Yeah, and we haven't really done a lot of exploration.
Yeah, so we had the Voyager flybys.
Yes.
That went back in the 70s. But then we had the New Horizons mission that did the flyby of Pluto and is still going.
Yeah, it's now in the, what do we call it? The place beyond.
Yeah, so I don't remember if it's gone actually into interstellar space or if it's still in what we call it the heliopause.
One of my favorite movies, incidentally. Interstellar, yes. But yeah.
Yeah, so it's headed out that way, and it's going a lot faster than the Voyager missions were. So the Voyager probes were. So it's
still getting data from those.
Yes, we are.
Wow.
Longest running. Let's see, we're not quite to 50 years yet, but we're closing in on 50 years for the Voyager probes.
Now, before we transition into what we're talking about with Artemis and what that whole thing is, what happened to Pluto? What happened to Pluto when it got declassified?
Okay, so what it really was is practicality. From ancient times, there were 5 planets. There was, well, technically there were 7 because the moon and the sun counted as planets for the ancients. But you had all the planets out to Saturn, and that's it. And that was all there was until the 1600s. And then they discovered Uranus. And then they discovered Neptune. And then in 1940, I think it was 48, they discovered Pluto. And we're like, wow, cool. Now we have 9 planets. Well, then as we kept looking out in that area, then they discovered Eris. And then they discovered, I can't remember what they named the next one. And then they discovered another one and another one and another one. And there are literally hundreds of these, which we now call dwarf planets, out beyond the boundary of the orbit of Neptune, which we call the Kuiper Belt.
Yes.
And so the International Astronomical Union, the IAU, decided that it made more sense to simply change, or not even change, to firmly define what a planet was. Because we really hadn't up to that point. A planet was simply something that went around the sun.
Okay. A lot. Yeah, okay, gotcha.
And so what ended up happening is they said, okay, what is a planet? Well, a planet is something that is going around the sun. It has cleared its orbit of debris. So meaning that it's the main thing. Anything that's left over has long since been swept away or taken in to the planet itself. That doesn't count moons, obviously. Moons are in a controlled orbit around. So Pluto hasn't done that. What we have found is you have Pluto and Charon. Of course, those are the main moon of Pluto is Charon. Charon is almost the same size as Pluto.
Okay.
And then they found Nix and I can't remember all of the names. Cerberus, I think they named another one.
Wow.
And there are basically 5 little mini moons all going around Pluto. But in addition, because of the shape of Pluto's orbit, there are other dwarf planets and other Kuiper Belt objects out there. And in composition, Pluto is actually more similar to a comet than it is to a planet.
Just a big
ball of ice.
Okay.
We call comets dirty snowballs. That's a lot of what it is. Now, Pluto is large enough that it has a circular shape. So gravity has shaped it into a sphere, which is another one of the requirements, but it hasn't cleared its orbital path. And so they said it makes more sense because there are so many things like Pluto out there, even if Pluto's the largest of them, to say Pluto is a dwarf planet, and then we have the other 8 that are the true planets. Now, not all astronomers even agree with this. Some planetary astronomers think that it's an artificial designation and it makes no sense. For the IAU, practicality was the main thing. If we have 8 planets and then we have dwarf planets, that's easier to manage than if we literally have thousands of planets.
So it's easy for us to catalog them.
Yeah, it really is more of that. It's not because Pluto is less interesting or less important. It really is a matter of cataloging.
Well, okay. So we have our own moon. And now there's an interest in building a base there. And there's this whole new rocket system that is being developed. There's Artemis. Let's talk about that as we start to wrap things up with you here today. But tell us about Artemis, why this is so significant, Orion, that whole mission that NASA now is embarking on.
All right. So we have not had our own rockets, like manned rocketry, since the end of the Apollo missions. Well, we had the space shuttle, and then we had the Apollo missions, and then the space shuttle. Once they, I can't remember the term they used, decommissioned the space shuttles, we didn't have a replacement. So right now, for us to get Americans into space, we have SpaceX, which is just happening in the last few years with Tesla, or Elon Musk. But as a national system, we can't send people into space unless we hitch a ride on someone else. And that has been, I think it's in Azerbaijan, but it's using Russian rocketry. And so we go up to the International Space Station using those, and we come back using their systems. And that means that if theirs isn't working or if theirs are not available, we can't go into space. Now, SpaceX has been doing a lot, and they have been making a lot of progress, but we want to kind of keep NASA as the national way of getting up into space. And so there have been a lot of programs that have kind of started and stopped over the years. And part of the problem with that is there isn't a lot of consistency on NASA's funding from year to year. It fluctuates. And so they have an issue with knowing how much money they're going to have available. But over the last few years, they've had this Artemis program. And the Artemis program is to make a new delivery system that will allow them to launch rockets, manned rockets, out into space again. And the idea is to establish a permanent base on the moon. And people say, well, why do we need to do that? One of the reasons for doing that is the lower gravity and the lack of an atmosphere. So when we want to launch objects into space, whether they be manned or unmanned, we have to overcome the pull of Earth's gravity. Plus, we have to angle everything just right to get through the atmosphere, because the faster something goes, the more heat is going to build up as the air actually rubs against the object. That's where shooting stars come from. They're basically pieces of dust that, because of friction in the atmosphere, burn up.
Okay.
So if we could establish a permanent base on the moon, we could actually we could build things just for being in space. We wouldn't have to worry about adapting it to an atmosphere and space as well.
Okay.
And so that would be one thing that would be easier. Another thing that would be easier is that the moon's gravitational pull is 1/6 that of the Earth. And so launching would take less fuel.
Okay.
So you could actually launch things into space much, much more easily. In addition, there's a lot of scientific research that could be done on the moon that we can do some of it in the International Space Station, but we would have a little more space to move around in, and it would be a little easier to build permanent structures on a rocky surface rather than in space in an orbit that has to stay stable.
Now, has the space station and all that we've done on the space station prepared us for being on a base on the moon?
To some degree, I think so, because even on the moon, there is, obviously a tangible pull of gravity, but it's a lot less. And so on the space station, generally speaking, they're in what we call a weightless situation, where it's not that there's no pull of gravity, but that gravity is completely balanced out by all the other forces. And so you feel like you have no weight. On the moon, we would have actually some weight, which would make some scientific experiments much easier to do than on the space station. And so being in space and having to work in these different kinds of conditions on the space station is definitely a good preparation, although it wouldn't be exactly equivalent to being on the moon.
Wow. Okay. So I could probably talk to you for 6 or 7 years about what's going on and all that. But are you excited about what you're seeing with Artemis?
Yes, I'm cautiously excited. I'm a little worried that something will happen and they'll decide, nope, we're going to start over again. Because that sometimes does happen because it's the National Aeronautics and Space Administration. Because of that, for example, if Congress decided there wasn't the funds available for fully funding NASA for a year, they would have to cut programs in order to keep functioning. And so because it's got so far to the point that they're doing these tests, they're preparing for these test launches, I'm getting more excited. I've been cautiously excited up to now, and now that they're actually at the point of we're testing, I'm hoping that this is still really going to happen, that they've gone far enough that they're not going to. So
it's not that you don't have faith in the ability to do it, it's the faith in the line item that it might be.
Yes. Yeah.
In Congress.
Yeah. The science is there. The ability is there. And the interest in it is there. I think it's just a matter of keeping it going now that we have this forward momentum.
Dr. Terry Gee, thanks so much for coming and talking to us today. Really interesting stuff. As I said, I could probably talk to you for about a year, and I'm that curious about this stuff. So we'll have you back sometime, maybe. And in the meantime, go visit her at the Barlow Planetarium. That's at the Fox Cities campus in Menasha. That's all the time we've got here today on UWO Now. We hope to hear from you next time.